Yeah, guys. This is the continuation of the previous solution. Okay, this is all it right here. Okay. As you guys know, we haven't yet implemented these methods, and I'm planning on doing so on the next video, not this one here, because this one here, to be honest, this is the most interesting part of this entire solution. And again, feel free to simply forget about this exercise and try to check out other ones, because to be honest, on this solution here, what I did is I decided to do things my way. That is to say, I'm gonna do things that we were not required to do. Okay, remember, for us, we simply have to display the rows, the columns, and the diagonals that contains ones or zeros only. But I'm not gonna do so. What I'm gonna do as for our diagonals and sub-diagonals, I wanna also display the positions where zeros only occur and ones only occur. Not necessarily all the positions, right? I mean the beginning and the ending of the diagonal of the diagonals where we only have zeros or ones only. Again, if it's a bit confusing, hopefully it's gonna make sense as I move on. Okay, before I even say a thing, what you want to understand is I'll be using a multi-dimensional array. Okay, not just a 2D but a 3-dimensional array where I'll be having arrays of what? I'll be having an array of arrays. Okay, now the outer array will contain arrays, of course. Now, the inner array will contain two arrays, two single-dimensional arrays, and the first array will be made up of 4 elements. The first element contains the row of the beginning of a diagonal that contains zeros only or ones only, and the second element will contain the corresponding column. Okay, the beginning column of a diagonal that only has zeros only or ones only. Okay, now the third element will contain the end position, the end row. Okay, yes, the end row for a diagonal that contains either zeros only or ones only. And finally, the fourth element will be the end column, right, of a row of a diagonal that contains either zeros only or ones only. Again, it will be even more confusing the more I say it, but when I actually do the coding, that's where things gonna be much simpler. Okay, now let's jump onto it right away without any waste of time. So I'll go measure diagonal 0. Zeros. Okay. Ideally, right here, measure diagonal zeros. This multi-dimensional array will contain all the diagonals. By all the diagonals, I mean their beginning position and their final position, their end position of diagonals that only have zeros. Okay, now go measure diagonal ones. Now you can guess what this is here for. Okay, now boolean contains on major diagonal. Again, this tells us whether or not we do have zeros only or ones only in the major diagonals. Okay, let's continue. Oh, okay, now that is actually taking me to another point, and that is, you see, we've got to create these methods. I mean this method called find major diagonals. Okay, this method, public static, it's gonna return a 3-dimensional array, a multi-dimensional array, and it's gonna be called find major diagonal. Yes, and it's gonna receive 2 arguments. Of course, you can guess the first one, and there will be the matrix, and the second argument will tell us whether or not we're checking for zeros. Okay, so it's gonna be boolean 2-dimensional array called matrix. Go to the next line. Now check zeros. Yes, it's gonna be called check zeros. Again, we're gonna take care of all of these methods later on. Okay, because right now I want people to have a feeling of what's going on. I don't want the complexity of a method to get on our way, right? Okay, now that I've got that is exactly what I want to invoke. Up there. Oops. Alright, what is it I am checking for? I'm checking for zeros, which means I'll pass through. And right there I'm checking for ones, so I'll pass false. God, false. Yes, I'll pass false. Now again, let me rephrase this. You see this array here, the major diagonal zeros, what it contains is it's an array that contains 2 single-dimensional arrays. The first array has 4 elements. Basically, those elements are responsible for storing the position. Of course, the position has the row and the corresponding column, right? So we're gonna have the position, the beginning, the initial position, right, and the final position for the diagonal that contains only zeros. The same idea happens. Now the last array. Remember, I said we're gonna have an array that contains 2 single-dimensional array. So I've explained the first single-dimensional array. The second one will contain either 0 or 1. Okay, that is to say, that position. Okay, remember the first array, the one that contains 4 elements. It basically contains the positions, the beginning and the end of the diagonal, right? We're dealing with. Now, the second array will contain only 1 element, and that element will tell us whether or not we have zeros on that particular diagonal or ones. Okay, I'm hoping that did make a little bit of sense. Now let's continue. Here's what I'll do. I wanna do the following. Now this is what I wanna do. I wanna have an index which will play two roles. In some way it'll be used as a column, and sometimes it will be used as a row. So that's why I just decided to go row column 1 is a row column 1 less than major diagonal zeros dot length major diagonal zeros. No wonder I did not get IntelliSense there. And it has an end here. And row column 1 is less than major diagonal. Let me copy and paste it up there. One's dot length. Now I'll go row column 1 plus plus. Right. You know what, you guys, let me write something down for a moment. Yeah, guys, I thought it would be much easier if I explain with an example. You see, remember I said this array here, these two arrays, I'll explain one of them, right? Because the other will follow the same idea, okay? You see, now what I said we're gonna have an array, like the outer array. So now question is, how many elements is the outer array gonna have? It's gonna be, you see how many diagonals here? Let me count them. So it's gonna be this one here. I'm hoping people are following what's going on. This one, the one that started index, the one that start at this element here, then ends right here. So that's gonna be number 1. Number 2 will be this one that start over there, then ends right over there. Okay, now number 3 is gonna be this one here. 1, it starts there and then it ends over there. That's our third one. The fourth one will start right over there and then end right over there. Now the fifth one, it starts there and then ends there. Okay, now the sixth one will probably be the main diagonal one, right? Now the seventh one will be the one that starts here and then ends right over there. Now the eighth one start over there, eighth one ends over there. Now the ninth one, it start over there and ends right over there. The 10th one will start right there, ends over there. Now the 11th one will start there and then end over there. Okay, so that's basically tells us that we're gonna have 11 elements in our outside array. Now the question then becomes, what is it that's going to be our element? Okay, it's gonna be okay, now remember we're gonna have 11 arrays. Now each of these arrays have 2 elements, and both of these elements are arrays themselves, right? So the first array will contain 4 elements. Now let me make you an example. You see, for instance, for this diagonal, the one that starts right over there and then ends right over here, it will contain, the 4 elements will be 0, 1, and let me count 1 0 1 2 3 4 5 6. So it's gonna be 0 1 and 5 6. Yes, those are gonna be our 4 elements. Okay, basically, again, the first array contains the positions, the beginning position and the end position of the given diagonal. Okay, now the second array contains either 0 or 1. Okay, if it contains 0, it simply means that diagonal, the one we defined on our first element, contains ones only. If it contains 1, like if the second element contains 1, if the second array contains 1. Now if it contains 0, bear in mind again it only has 1 element. If it contains 0, it simply implies that there are zeros only on the diagonal we specified on our first element of the outer array. Okay, again, I don't know, guys, perhaps it will make more sense the more I continue coding. Okay, guys, now that you know what, it would be better if I explain using this example here. Now here's what I want to do. I want to check if before I do that, let me create a variable called contains zeros on major. Oh god. Okay, I've got this variable here. I'm gonna initialize it to I'm gonna initialize it to false, and then I'm gonna initialize it to false. Now what I wanna do, I wanna check zeros only, right? I'm gonna do that by checking my measure diagonal matrix, my multi-dimensional array. It's called measure diagonal zeros. Okay, now question is, what is it do I put there first? Now that's the index for the diagonal that I wanna pick, right? Remember, we've got how many of them? 10 of them, because we started from 1 and we ended 211. So this number right there is gonna be some number between 0 and 10. Okay, however, it's gonna be called column row 1. Okay, now that will pick the first array we're working with. Now the second one will be one of the 2 arrays within our outer array. Remember, I said the first array, the array at index 0, contains the position of the beginning and the ending of our diagonal. Now we're not interested in that, we're interested in the second element of the outer array. So we're gonna put 1 there, and that second element is either 0 or 1. Now bear in mind the second array only has 1. It only has 1 element, so we've got no choice there but to put a 0. So we're checking if there we have a 1 or a 0. So if we have a 1, then we know that it's true. We've got major diagonals containing 1 zeros only. Okay, now this array here will contain the position, right? It will contain diagonal zeros. Okay, This will contain, we need an array that contains, oh gosh. Okay, now that we know we are looking for the positions, right here we'll pass again row column 1, and right there we'll pass a 1. Why can't I properly spell the word diagonal? Okay. No, a minute. I cannot believe these. No, that's what I'm looking for. The array, the first array, not the second one. Because by putting 1 here, it's going to return an array of only a single element. But if I put a 0 there, it's going to return an array containing 4 elements. Again, I've mentioned this before, what those 4 elements are. I'm repeating it again, however. So the first one contains the row and the second one is the column, right? And those two, they correspond to the beginning, right? Row and the beginning column. Okay, now the third element contains the end row, whereas the fourth element contains the end column. Yeah, now that we do have our position array, the next thing I want to do will be to go system.out.print. I want to use println though. I'll go all zeros on major diagonal from position at 0. Remember, this is my row for the beginning of our diagonal, right? Comma. This is the column now. From there to let me just put something like that and replace those numbers. So 0, 1, 2, then I'll put a 3 over there. And then finally I'll close this. Okay, now I've displayed the row, the diagonal positions, its beginning position and its ending position. Like, yes, I have displayed that. Now what else I might probably want to do? Okay, after I've displayed that, I'll check if I'll notify my contains on major variable. Okay, so if we haven't yet concluded that we do have zeros or ones on major diagonal, it is time to zeros major diagonal. If we haven't yet mentioned that we do have zeros on major diagonals, it is time to do so. Okay, so now we're done checking zeros only. Now let's check ones only. However, we only do that if we haven't encountered any zeros on the given diagonal, right? On the diagonal there is actually on this position, this one here. Okay, come on, it makes sense. There's no possible way we can have a diagonal containing zeros only and ones only. Come on, it doesn't make any sense. Okay, so first of all, we've got to make sure of that, and then secondly, we're gonna have to check if major diagonal ones major diagonal ones. We're checking again. That's row column 1. Row column 1. Okay, we're dealing with the second entry of our outer array, and then that second entry only contains one element, so that's why we need to put a 0 over there. Okay, now I'm checking if that is exactly 1, because 1 indicates that yes, we do have zeros only or ones only. Okay, yeah. Now again, just like before, I want to retrieve position. You know what, let me copy everything. Again, this is not the most efficient solution, guys. Okay, so here's what I'll do. I'll have my position, and then I'll go ones, all ones, not all zeros. Yeah, that's gonna be pretty much it, you guys. I don't think I might be missing anything here. Okay, let me get rid of that. Seems like there's no need for it. Get rid of it. Let me get rid of it. Okay, once I'm done doing that, you see, so far what I did is I've only checked measured diagonals. Now it is time to check sub diagonals. Really? That's why I'm gonna have to copy that the way it is. Okay. Oh, before I do that, let me copy something like that. Same numbers on. Now I'll say no same numbers on major diagonal. However, the variable that I wanna use is this one here, not that over there, not this. Okay, now it is time. This is the last part, you guys. We gotta deal with the sub diagonals. Remember here, the way I was talking about my diagonals, I was talking about those that start from left to right. Okay, that is to say, we're starting maybe from that element over there, and then we end right over here. Now I want to have something like starting from that element over there and then ending there, and then starting from that element over there and then ending there. You see, I'm hoping people can see the pattern here. Okay, so we're gonna take care of that as well. That is, matter of fact, that is exactly what I'm about to do now. On major diagonals. Okay, now the idea is pretty much the same as this one here. We're gonna have exactly that. However, sub diagonal 0. Now we're gonna use sub instead of major. Sub okay, now in regards to the method we don't want to call the find major diagonals method. We want to call a different one, and it's gonna be called find. I mean, you can make a guess. What is it gonna be called? It's gonna be called find sub diagonals. Okay, with that out of the way, now let's get to the core of this problem here. Okay, the ideal is pretty much the same like what we had here. So let me go copy and paste that. Oh, I mean, noise. Okay, we're gonna have something like this one here. Okay, I've been typing for quite some time, you guys. I no longer feel like doing it anymore. Again, right there we wanna use sub instead of that. I know I always tell people not to copy and paste, but I'm hoping everyone is clear here that without copying and pasting, this will be way too long than it already is. Now that I have my array, I wanna have something like that. Oops. Now I wanna check if it contains zeros only on sub. It's no longer a major diagonal, it's sub diagonal. So it's a matter of replacing sub with major with sub. I mean sub. Okay, it's gonna let me see. I mean, honestly, you guys, it's a matter of replacing sub with major here. On sub. Okay, am I missing anything here? Guys, feel free to let me know in case I messed up. Again, I was dealing with zeros. Now that I'm done with them, I've got absolutely nothing to worry about. Now I want to deal with ones. I want to check for ones. Again, it's gonna be a matter of replacing major with sub. Oops. Really? That is so bad. And now there's a way to properly align your code. To be honest, I kind of forgot how to do so. There's a way to make sure that your code is has correct indentation. Okay, sub. Okay, now we're replacing measure with sub. Okay, and right there we put sub. What else? Measure. Again, we're replacing sub with measure. One disadvantage of making videos outside is that people, they tend to greet you even if they see that you are in the middle of something. Okay, let's see, am I missing something here? Seems like I'm not. It seems like I am not. So that should be pretty much it, you guys. The only thing left to do will be to what now? Will be to implement those methods. All of these methods that are not yet implemented. Okay. Again, I'm substituting that with that. Okay, so this is gonna be pretty much it for this video, you guys. You know what? I'll see you on the next one. Okay, it's gonna be the last part of this exercise, you guys. That's where I'll be actually implementing all of these methods here. Okay, so cheers, you guys. Stay tuned.